Okay, so now we're going to use some trig models to answer questions. Okay, so this example, it's got the height, ht, meters, of the tide above sea level is modeled by ht equals 2 times sine pi t on 6, where t is the number of hours after midnight. Graph ht for t is between 0 and 24. All right, so you might be looking at that function thinking that doesn't look like our usual function because of the pi on 6, but once we sub in values, you'll see how it works. Now, first of all, what can we tell from the equation? The number outside of sine, or being multiplied by sine, is 2, so the amplitude must be 2. So we expect the max and min for this function to hit at 2 and negative 2. Okay, so let's just sub in some points. So when t is 0, what do we get? H of 0 equals 2 times sine of just 0, because pi times 0 is 0, divided by 6 is still 0. Now sine of 0 is 0, because the y value at the point where the angle is 0 on the unit circle is just 0. So that becomes 2 times 0, which equals 0. So our first point is the origin. Okay, now let's sub in the next point, which is 2. So what's h of 2? We get 2 times sine of 2 times pi over 6, or in other words, well, I'm just going to write that down, 2 times pi on 6. Or in other words, pi on 3. Now, sine of pi on 3 is, if we use our exact value triangle, so we got pi on 6 up here, pi on 3 down here, 1 root 3, 2. So pi on 3 is opposite over hypotenuse, which is root 3 on 2. Now, to graph that, root 3 on 2 would be like 1 point something divided by 2. And if you use a calculator, you get root 3 divided by 2 is 0.866 approximately. Okay, so at 2 I expect to be close to 1 but not quite there, so somewhere there. Now you know what I'd like to know? When would that angle inside the function equal pi on 2? Because remember, that's usually our first significant point on our graph. So when does pi t over 6 equal pi on 2? Because that's when, remember, sine of pi on 2 is 1. So we'll know that's when we know our graph will reach a maximum. Now, so if I divide both sides by pi, cancel out the pi's, times both sides by 6, we get t equals 3. So at 3, which is halfway between 2 and 4, I expect that the angle to be like pi on 2, and sine pi on 2 is 1, so 2 times 1 is 2. So let's just check that. Let's see what happens when at h of 3, we get 2 sine 3 pi on 6. I'm just replacing t with 3. That becomes 2 sine of pi on 2. Sine of pi on 2 is 1. 2 times 1 is 2. So I hit my maximum there. All right, so now I'm going to rub this out because that's kind of confusing me. This here. All right, now, so I can see that I'm going to have a shape like this. And then I'm going to turn around and hit the bottom. Where do you think I'm going to hit the x-axis? Probably at 6, 3 more units across. Now, what we haven't considered yet is the period. So if you remember, the period is always 2 pi divided by, usually if it's like a constant or b times t, we divide by b. So here, what's b? b is actually pi on 6. So it's 2 pi divided by pi on 6, or in other words, times 6 on pi. Cancel, cancel. That equals 12. So for every 12 units, it should repeat. So with that in mind, I expect after the origin at 0, we should hit the x-axis, or t-axis I should say, at 12 and be going upwards. Okay, so now let's see if, as we predicted, when t is 6, do we hit the x-axis? So let's find h of 6 equals 2 sine 6 pi on 6. What's 6 pi on 6? That's just pi. And sine of pi is actually 0. Oops. And that becomes 0. So it's correct, I do hit it there. Okay, so I'm going to do that. And now, as we would expect, we know what the sine curve basically looks like. So we would expect at 9 to be down at the minimum. And then back we go up and hit the x-axis at 12. Then 3 units later, we would hit the maximum. Oh, sorry, what did I write? 3 there. That should be a 15, shouldn't it? Because it's like 12 plus 3. Then 3 units after that, we should hit 0. Then 3 units after that at 21, we should hit the minimum. Then 3 units after that at 24, we should hit 0 again. So let's just draw that slowly. Try and make sure it looks nice and curved. Not like these. And there we go. Okay, so we've done A. When is high tide and what is the maximum height? Okay, so high tide is at 3 and 15. Now, what are these units again? It says where t is the number of hours after midnight. So 0 is like midnight. So 3 hours after midnight would be 3 a.m. So it's at 3 a.m. And then 15 hours after midnight, which is this one here, it would be 3 p.m. And what's the height? Well, the height, the y value, h value is 2. So the height is 2. And we're in meters, so we can say meters. What is the height at 4 p.m.? Okay, so now using our graph, we would approximate to be a bit under 2. So let's approximate that to say 1.8. But how could we find it a bit easier? We could solve the equation. So I'm going to rub some of this out. Okay. So now we're doing C, and we're going to try and find a better value than our approximation of 1.8. So this first value, 1.8 meters, that's an approximation using our graph. Now let's try and be a bit better than that. So in other words, we want to know the height when t is 4. So that becomes 2 sine 4 pi on 6. Or in other words, 2 sine 2 pi on 3. Now, using the unit circle, where's 2 pi on 3? That's an obtuse angle, so it's in the S quadrant, where this little angle with the y-axis would be just pi on 3. And then, so therefore, and because it's in the S quadrant, sign is still positive, so we can actually replace this with the equivalent sign of just pi on 3, because the angle with the to the horizontal is just pi on 3. And then using our exact value triangles up here, sine of pi on 3 is root 3 on 2. And that would just be root 3. Now, what is root 3 as a value, as a decimal, I should say? 1.73 approximately. So our guess of 1.8 meters wasn't bad. So now, the exam, if they had asked you to use your graph, then I'm sure your answer of 1.8 meters would have been fine. But if they wanted you to find it to like 2 decimal places or the exact height, that's when you would use an equation like we just did. So our better answer for this is 1.73 meters. Okay, if a ship can cross the harbour, provided the tide is at least 1 meters above sea level, when is crossing possible during the day? All right, so I want to know when the height is at least 1 meter. Now, if we draw a line across here, so like if I draw a dashed line at 1 meter in height, when is my curve above that 1 meter? From about here to here on the t-axis, and from about here to here. So in this time and this time, we seem to be above the 1 meter. So they're the times that we can move, but we need to find that more precisely. So in other words, I want to find those endpoints. So I want to know, when does the curve 2 sine pi t on 6 equal 1? Okay, you could do greater or equal to, but it's probably easier to just think of it as an equation, and then we'll look at our graph and figure out the inequality. Okay, so to solve this, we divide both sides by 2 on the outside to cancel. We get a half. Now, using our exact value triangle, sine of pi on 6 is a half. So we now know that our angle, which is pi t on 6, could equal pi on 6, or at least that's the acute version. Now let's consider the unit circle. All right, so when is sine positive and the positive half? So that'll be in the A quadrant and the S quadrant. Okay, so, and that little angle here is pi on 6. And that little angle here is pi on 6. Okay, so let's go around. We're going to just go around once. So there is just pi on 6 from 0. So pi on 6, we do want that acute angle, so I'll keep it there. And then if we go all the way around to pi and then back pi on 6, it's like pi minus pi on 6. All right, but that's only 2 solutions. So that must be this one here and this one here. What about these 2? To get 2 more solutions, we're going to need to go around again. So let's keep going. Around to 2 pi, and then up another pi on 6, so our next solution will be 2 pi plus pi on 6. And then all the way around to 3 pi, then minus pi on 6. Okay, so we get pi t on 6 equals pi on 6. And then 6 pi on 6 minus pi on 6 is 5 pi on 6. And then next one, 12 pi on 6 plus pi on 6 is 13 pi on 6. And then the last one, 18 pi on 6 minus pi on 6 is 17 pi on 6. Now look at this. I've got, sorry, one second. I've got pi t on 6. So first, let's times everything by 6 to cancel out this 6 here. Times up by 6, and now I'm going to times everything over here by 6. Basically, all the 6's cancel out, which is lovely. But then I also want to get rid of this pi, so I need to divide by pi on this side. So I need to divide by pi on this side. All the pi's cancel out again, and I'm left with t equals, well, that's just, both of these have cancelled out, so it's just 1. And then we get 5, 13, and 17. Let's have a look at our graph to see if those values make sense. All right, this first intersection does look like it's above t equals 1 approximately. And then this intersection, well, the way I've drawn it, it looks a bit closer to 6 than it should be. But that's because, you know, it's not a perfect graph. But it still makes sense, our next value of 5. This next intersection looks like it would be about 13. And this one also looks like it would be about 17. So our answers make sense. So to answer the actual question, the question was what times? If a ship can cross the harbour when it is at least 1 metre above sea level, when is crossing possible? Well, it would be between 1 a.m. and 5 a.m. That's what this interval here is telling me. It's between 1 a.m. and 5 a.m. because that here is 1 a.m. and 5 a.m. And then this one, next one is, well, 1300 or 1 p.m. and 1700 or 5 p.m. would be this part here. So they're the times. So let's write a sentence to answer it. Therefore, the ship can cross between 1 a.m. and 5 a.m. and between 1 p.m. and 5 p.m. So we've answered our question in a sentence because it was asked in a sentence, and that's how you use models to problem solve.